We're now going to cover part 2 of our lesson on two-stage completion methods. And as you'll see, these are going to be methods where the action will run when the first previous stage finishes, or the second previous stage finishes. So in essence, it's really like the concept of a logical disjunction. It's an or. It'll run in either case. So the particular completion stage method we're going to focus on here is acceptEither, which is triggered when either of its 2 previous stages complete. And you can see here, that's what the signature looks like. It applies a consumer action that handles either of the 2 previous stages results. So it's logical disjunction. And as with the then compose method we just looked at, 2 futures are being used. One is the one that's used to invoke acceptEither, which I don't show here because it's not part of the signature, but since it's not a static method, you realize it has to be called in the context of an object. And then the second is shown here as the first parameter. It's the other completable future that's passed to acceptEither. So those are the 2 completable futures that are going to be used. It returns a future to void. So it's a bit like then except, where it returns a completable future to a non-return value. It just indicates it's done, but it doesn't give you a result as a consequence. I honestly don't know why they didn't call this then acceptEither. That would seem a bit more consistent with the naming of the other methods, but whatever reason they called it acceptEither. Maybe they thought then acceptEither was going to get too long or something. We often use acceptEither at the end of a chain of completion stages, very much like we use then except at the end of a chain of completion stages, because they're sort of parallel methods in some ways, but one is triggered when a single stage completes, whereas acceptEither is triggered when 2 previous stages complete. So I was searching for a metaphor that would show the end of something, so I came up with a caboose, which is at the end of something. So let's take a look at a really fun example that illustrates the use of this particular mechanism. So what we're going to do is we're going to have 2 completable futures created, one called quicksort_f and the other called merge_sort_f. And as the name implies, and if you look at the code, you'll see what's happening. We're going to have a list, and we're going to have quicksort. We're going to quicksort the list in the background, and in parallel, we're going to merge sort the list in the background. So you probably remember either your data structures class or your algorithms class, where people make a big deal about asymptotic time complexity of sorting algorithms. And we talk about quicksort versus merge sort versus heap sort and so on and so forth. So rather than sit there carefully looking through the code and trying to guess which one is going to run faster, this is a modern, brave new world of many cores, multi-core. We'll just have as many different sort algorithms run at the same time. In this case, we choose 2. We could have more, but we choose 2. We let them run, and whichever one finishes first, we use that result. So it's a pretty clever way of cutting the Gordian knot of asymptotic time complexity that has plagued us as computer scientists for decades. So here's what it looks like. We take the quicksort_f and the merge_sort_f completable futures, and we connect them by acceptEither. And this method will be invoked, or rather the action of this method will be invoked when either the quicksort computation finishes asynchronously or the merge sort computation finishes asynchronously. So whichever one finishes first, that's the one we're going to choose. And the particular action here that we're going to do when either one finishes is we're going to go ahead and print the results, which will now be sorted as mixed strings to the standard output. So I think that's a really, really cool example of what you can do with modern multi-core processors to not have to worry about the time complexity or the running time of multiple alternative solutions to the same problem. Just run them all at the same time and let acceptEither sort them out. Interestingly enough, when acceptEither accepts the first result, it does not cancel the second future. The second completable future is still active, and when it is done, the result will be available to anybody who wants to get it through that completable future. And the reason for that is it's not necessarily the case that just because this particular computation didn't want the result, some other computation didn't want the result of that asynchronous completable future. Now, as with the other discussion we had earlier about then compose, acceptEither can also be run asynchronously if a long duration consumer is applied. Now, this is not really a long duration consumer, so it would probably be overkill to use it in this case. But if you're going to be doing something that's going to take a while to run, acceptEitherAsync could be your solution. So that's the end of the discussion of two-stage completion methods. We'll see that there's other types of completion methods, which I term arbitrary arity methods, that can be used to wait or can be used to be triggered reactively upon the completion of more than two things. And those would be the any of and all of arbitrary arity methods. We'll talk about those later.